Going through homework first, start with worksheet. Start with worksheet here. Stop talking. 20 was our overall total. So 10 were seniors. What did we decide for this class? 5 and 5? Yeah. Hold on. No. Yeah, I guess he's not here. Thank you, Trey. So 5. There's 6 juniors. 2 are female. That leaves 4 here. Where did I miss? Did I miss something up there?
3 of the sophomores.
3 of the sophomores are males. So how many total sophomores are there? 4. Which means this is going to be, what's this one?
12.
So that's just get our total. So probability of junior or female. So that's an or. These 2 events are what? Not mutually exclusive. So we'd have to do probability of junior. And then should be a minus. Probability of junior is, and this is one where I wish we could all work today. This is one where I always say you have to reduce. Anytime you're doing something like this, don't reduce until the end because then you're gonna have to like reduce and then try to combine not like terms. It just makes it easier. So it's our probability of female.
Sorry, that's just 8 out of 20.
Minus,
2 out of 20.
which gives me,
12 out of 20.
which is, so again, all of that is showing work of what I need. This one, what do I know about sophomore and senior? They are mutually exclusive, so what? Just add, I don't have to subtract anything. So probability of sophomore is 4 out of 20. Probability of senior is 10 out of 20. Which gives me 14 out of 20, which gives me what? I can't remember if I talked about this class or just my other class. Fraction, decimal, percent, regardless of what they ask, all of those are interchangeable with my class, the AP exam. Probability of junior and a male. 4 out of 20, which is 1/5. And I didn't have to do any math because I just saw where they directly intersected up there. We started to get into math at the end today a little bit. Washington, D.C. attracts 16 million. You don't even really need that. So we have 2 different random variables. One of the random variables is whether or not they do what? Whether or not they go where? Which one? What's one of the events? So history or not. My other random variable is what? Airspace or not. So you can do it as a 2-way table or a Venn diagram. It doesn't really matter which way you do it. I'm going to do airspace or not, history or not. It gives it to me as decimals, which means my overall total should be what? 1. That's my 100% there. It says 44% do go to the history. So that is an overall total for history, which goes here, which means how many don't?
56.
It says 38 do go to the air and space, which means how many don't? And then the only other thing it gives you is that both is 0.3. And then you just fill everything in from there. So what's left for here? What's left for here? And regardless of if you did a 2-way table or Venn diagram, these should be your 4 numbers regardless. Questions on that? So it would look basically the similar. This is where it's This is overlapping where you can see where they overlap. This is in the box but not in the circles. But just make sure that you don't write 0.38 and 0.3 because if 0.08 is here, that only leaves 0.3 for that section.
That's the other way.
As far as like left and right. So I was talking about.
No, 0.3's in the middle.
0.3, yes, thank you. Sorry. If 0.3 is here, so it's right opposite. If 0.3 is here, that only leaves 0.08 for here, thank you. Which leaves 0.14 here. So then my questions that go with this, this one is ones that you're basically just saying, did you do it right? But I want to write out the way that it would be written. So probably they go to the National Air and Space, so they do this, but not to this one. So what's my answer?
8%.
We agree that it's that space, right? So how could I write this, and this is not part of what you had to do, as one of these? What's the first thing it told me?
Air and space, not, that they go to the National Air and Space, but not to the Museum of Natural History, so it would be and the complement page.
So they do go to the air and space, and they don't go to history. That's technically the way this one would be written. Probably that they do not go to either. Well, what's my answer? 48%. That one would be written as P parentheses what?
Complement A and complement A.
Like I said, I didn't ask you to write it like that. I just need to know that you can kind of think through it that way. This problem. I would get in the habit of when you get a problem like this, start writing it out, everything you get when it's like I don't have any direction of where to go. So, what are my different events that it talks about? What are the different events that it talks about? After midnight and accident. So I'm going to use A and M. So first thing, on New Year's Eve, probably the person driving after midnight is 0.32. So I'm just kind of starting to write stuff down because I don't know where I'm going yet. Probably the person having an accident is 0.09. Probably the person having an accident after midnight, what does that actually mean? P what?
A and N.
Which is, and what does it ask for? Well, when I'm dealing with or, I have to know whether the two things are what? Overlapping. Are these overlapping?
Yeah.
So my equation is what? It doesn't either one.
Minus probability of A.
The math behind this problem is not hard, obviously. It's knowing that that's what I was supposed to do and that's what those things meant. This is a very typical problem. It's actually maybe on the easier end of the typical problem. And I end up getting my answer as what? And the very last problem, I always have people go home and be like, I have no idea what to do. It's because it's so easy that you think you don't know what to do. We have, our committee has 3 English teachers, 1 French, 1 Spanish, and 2 parents. So how many people is that? 7. What's the probability that they're a foreign language teacher? Just 2 out of 7. That's your answer. Alright, so book work. First one is, what goes here? How do I figure out what goes here? Or why do I know what goes there? They all do what? add equal 1, so how much is left? 0.09. Why? Because the sum of all the probabilities equals, so this is what's the probability that a Canadian's mother's tongue is not English? So here is English, so what do I do with that? Which gives me what's the probability that a Canadian's mother's tongue is anything other than English or French? If I ask you to show work on this, what's one way you could do it?
Wait, sorry. Complement of it? Or wait, no.
I would just do English.
Or you just do Asian plus 100.
Is there anything wrong with that? No, because there's, otherwise I'm going to do 1 minus probability of E or F. And that one is more work than this one is in this case. So even though this is kind of set up like a complement, it's absolutely fine to do it that way. So you're doing 0.06 plus 0.09, which gives you 0.15. Students eating breakfast. A lot of this is just reading the table. Who are the individuals in this one? That's kind of a review. The students in this urban school. What are the variables being measured? Gender and breakfast regularity. So it's 2 variables, it's a 2-way table. Probability that's a female. What? 270. Are y'all okay if I just say the numbers and not talk about reducing them right now? You should reduce them as your answer, but I want to go a little bit quicker. 275 over 595. Someone who eats breakfast regularly would be what over what? 300 over 595. A female who does eat breakfast regularly would be 110 over 595. And then this one, we actually would have to do it because it's an or as what's the probability that they're female? Should have said something. 275 out of 595. Now, if I see somebody do this and right underneath it, I will count off. Because what does this mean? Is that a probability? No. So don't contradict yourself because to the AP grader you're saying, I don't understand what P parentheses means.
So we need to say over.
Mm-hmm. And even if you put it all over, like do it all and then do it over 595. Plus, what's my probability that they eat breakfast regularly? Minus 110, right? That's the right one?
Yes.
And then you get your answer, reduce it. I think we're good with that part. A lot of this is just making sure we're reading the table, everything correctly. So same exercise, it says create a Venn diagram. So this 2-way table just had 2 options in each direction. Converting that to a Venn diagram, just like I said from the problem today, is still going to have these exact 4 numbers placed in them. So if I do this as, say, B is eats breakfast and M is male, so how many are going to be in the overlap?
190.
How many of them eat breakfast but are not male?
110.
How many go here?
130.
And so going back and forth between a 2-way table and a Venn diagram is super easy because whatever is not the totals is your numbers for a Venn diagram. I'm going to talk through these, trying to go quicker. Probability to eat breakfast or male, you have to do probability of breakfast plus probability of male minus probability of breakfast and male. What's the probability they eat breakfast? 300 out of 595. Probability of male, 320 out of 595 minus 190 out of 595. Answer reduced. What does this one mean?
Probability of females and don't eat breakfast.
A female who does not eat breakfast regularly could be condensed as calling it female who does eat breakfast regularly, only because there's 2 options here and 2 options here. So to complement, there's only 1 option left. And that one would just be 165 out of 595. Alright, so this one, it does question marks. There's nothing different than me calling those X's. What's the probability of finding 3 people in a household? The probability of finding 3 people in a household is the exact same as probability of finding 4. We'd do this problem if it didn't tell us that. No, because all we would know is what these were together, but it told us that those are the same, which means this is X, this is X. So I could do 0.25 plus 0.32 plus X, and so forth. These add up to give me what? Just these. What's this give me?
0.68.
So 0.68 altogether. So I have 0.68. So how much is left? 0.32. What do I do with 0.32? Divide by 2. Something like this should be very easy for you to understand how you have to show work for a multiple choice problem at this point. This is something that I'm hoping y'all did good with. I'm glad I included this. We've kind of talked about it here and there, but I don't want you to get mixed up. All it's saying is, hey, when I used the table of random digits, my options were 0 to 9. So how many options did I have? 10. Well, they're all equally likely. So how many of them are greater than 7? 7 or greater. 7 or greater. How many of them are 7 or greater? 3 of them out of 10. That's all that was asking about. 20 of a sample of 275 students say they are vegetarian. So if I want to, like, let's say I'm doing this one like it's a problem, and I want to start writing stuff down because I have no idea where this problem's going to go. Tell me what to write.
Probability of student. Oh, wait. Vegetarian.
Equals what?
20 out of 275.
So I'm just kind of writing as I go. I don't really know what to do there yet. Because now I'm kind of mixed up, but maybe I can kind of figure my way out of it. Maybe writing this one out. Maybe at this point I look at this one and go, okay, now after today you will write it out and be fine with it. But right now I'm like, I don't really know how to write that, so I might want to go a different direction and I could do a visual. So I've got vegetarians, not vegetarians. How many other variables do I have? Eat eggs, eat fish, or neither. So would I want to do a Venn diagram for this? 2-way table is going to be easier. So vegetarian or not vegetarian. And then my options are what? Eggs, fish, and both, or neither. Is that right? Or do I know all that?
Fish and eggs but not fish.
Both. I'm write it separate. Eggs and fish. What's another one?
Just eggs.
Alright, so what goes here?
275.
What goes here? Which means what would go here? We might not eat it, but. So, of these vegetarians, so now I'm only on this top row. 9 eat both. 3 eat eggs but not fish. And 8 eat neither. See any issues? No, because those add up, right? Those are my only options. What is the probability that the chosen student eats neither fish nor eggs? Choose one of the vegetarians at random. So did I even need any of this? So it actually ended up being that it gave us extra information, and this is all it asked us about in general. I've seen this problem written with the exact same information and ask you a completely different problem, so be aware of that. And then what's the probability that they eat neither eggs nor fish? 8 out of 20, which is 0.4. Questions on any of the homework?
I'm still confused because it's still like it doesn't even specify like the question asked about like the vegetarians like at the very end of it, like it's just the chosen student, but it could be just in the sample.
It's that part. Like it said it in a separate sentence, and
Oh.
it should have said it together. I agree.
Okay.
I would have written it. I would have liked it. Here we go. Yeah.
These are-
Other questions with homework? Everybody got a